Okay, so here we have the Matsushita or Panasonic Amiga 2000 drive, and we've got our Amiga test kit loaded, and we're just going to get our probes ready here. Our probe. This one isn't as convenient as the other one. It doesn't have the holes empty. So I'll just clip onto the case and that's our signal. So again, our meter is set for 2 microseconds per division and 5 millivolts for vertical per division. And we're set on AC coupling. And we're going to go to the floppy drive section and select DF1. It's weird, the way it says DF1 is not present, but it's working. I mean, oh. What's going on there, huh? Really seems like seems okay. Or now it's okay. So what could that be besides maybe maybe when it's inserted, it's pushing down on the disc a little too hard or something. You know, because it's almost like the spindle in here is getting pushed against the top of the disc, maybe. Motor's not running. Yeah, we got to do something about that before we proceed. And the fact that it makes more noise when I rotate it means that gravity is helping us, and that I believe that would mean that the top is scraping against the spindle. Okay, so I'm glad this happened. Third drive, third problem. So the top head isn't aligned with the bottom head. It's not. It's off. So there's an adjustment you can do right here. Just pop this clip off here. And then you can access loosen the screws, move the head a little bit this way. Tiny bit more. Amiga test kit will even tell you that, you know, if you got errors that are just different, or just on one side or are different. And this misaligned head might be why it's scraping, because, yeah, I think it's the head actually scraping on the disc. Something about moving the head in one way too far maybe curves it up or something. It definitely has some sort of weird geometry going on there. Okay, let's try this again. So yeah, Amiga Test Kit does have useful information as far as that goes. Stick a disk in. Yeah, I mean, you can see that the relative, so the lower side is okay and the upper side is off. So, well, not perfect. So now as an experiment, we can see, let's loosen the head a little bit if we can. I don't really think I can because this bracket's in the way. Let me take this bracket off. Hold on. There's this bracket that kind of stabilizes the ribbon cable, but it looks like it comes off. Is that going to affect anything else? Yes, it's going to... Shoot. It's going to make it so that the bar that the head rides on this side is going to be flapping around, and that's really going to mess us up. See if I can maybe what I can do is just loosen that one screw. I just don't have very good access to it. Okay, we'll loosen that one screw, keep the other one tight. So let's just see if I can give you a close-up of the screws I'm talking about. Yeah, so you can see there's two screws there. So I've loosened that one because it's kind of underneath this bar, because I think I have it too far. It's like not even in the zero head, the zero track position. It's pushed a little too far, so I get my screwdriver in there. The minute the computer turns on, it moves it back a little bit, and I can't access that screw. So I loosened that screw that's under there, and I'm going to use that other screw, hopefully, to get it where they're relatively even. Now the question is so we know we can do that. We know we have that tool. We can use Amiga Test Kit to do that. But I mean, for demonstration purposes, should I show? See, now the lower side is not perfect either. So I mean, there's a problem with the alignment on this drive. Because the lower head is fixed to the track motor. It's the upper head that you're supposed to align to the lower one. So if you know, hypothetically, we could do the track alignment first and make sure that our lower head. Oh, and also, you see, it says side 0 is lower and side 1 is upper. On the circuit board, it says T1 and T2. Let's just before we do anything, let's just look and see which one of these is further off. That's a nice strong signal. That's on T1. What is T2 doing? Kind of the same thing. So I'd be better off with that, since we're not, I'm going to use that calibration disc so it doesn't do that. There we go. Oh, it's still doing it. Huh. Okay, anyway, so we're at 5 volts per division, so 5, 10, 15. Seems like it's nice and strong, but we're going between about 8 and 15. And on this one, we're going just maybe slightly lower. Oh, but now we see that our head alignment between the heads is really close, and the upper one is actually the one that's off. So let's try a little live adjustment here. This is going to throw it off instantly. Man, this is going to be just about impossible to... This is not an easy thing to do. Okay, I have fiddled with this thing until I got it, what I believe is the heads are aligned together. There's only one, and hitting F2 or checking, basically it's got three options. You can do it on cylinder 0, you can do it on 40, which is the halfway point, and you can do it on the last cylinder. And it really depends on a little bit on what disc I use. These Maxell HD discs that I don't like, they give errors. This Workbench 1.2 extras disc, I think, was a little off on the high cylinder. It's just, I think I can eject it while I'm doing it. It's no big deal. Yeah. Only thing that's weird is the calibration disc for Amiga alignment, you know, just has an issue with this drive, and I can't quite sort it out. But let's try to do the alignment using another disc, I guess. And the motor's not turning. Come on now, what's going on here? Oh, wrong disc. Okay. Okay. So let's see what we got going on with our calibration, our track calibration. It doesn't seem that bad actually, because that's 5, 10, 15, going up to 17. I know I've messed with this drive though, for sure, so we're just going to verify we're going to be good to go here. Ah, there we go. Easy. So we'll get some errors on here when we start messing with it. And they're pretty close to each other. Okay, so let's give the head a turn. See. Now we're going in the wrong direction there. Okay. Ah, interesting. I think what we're getting here is we're getting the signal from both alternating or something, you know? It's weird. So we're at 10 millivolts on the lower. Let's see if we can just get that a little bit. I mean, are we supposed to be even like this, or are we supposed to have some kind of a jumpy difference here? This is strange. Now when I go lower, it does it again, and then we've got the lower. Let me zoom you out a little bit so you can see what's going on. See how the oscilloscope relates to the So obviously the jumping back and forth, let's go the other way. We got a huge, oh, that's so far out, it's nothing, okay. Okay, so look at that. That's like a big jump between one signal and another, and we have bad. So maybe we need to just get them so they don't really jump that much. It's too far. Too far again. Let's start to lock down one of these screws here. It's not where I want it though. That's pretty good there. I locked it down and it came out of alignment. Can you say fiddly? Let's try tightening this one that's a little bit loose. And no. It's not going to do it all. I think we got it. We got it. So let's see what sort of result we get from that. So this is our workbench. This is a workbench 1.2 disc. Let's see if we're good or we're full of crap. No. We're not good, not at all. Let's try another disc. Oh, there was a reseek. No. We're not going to work. Oh, this is the fun part. Man, I just cannot get track 80 to be aligned, no matter how I try. So I think this is pretty much the best I could get it. Put a disc in. Unfortunately, I just can't determine what I should be seeing on my oscilloscope. But 0 is fine, 40 is fine. We go to 79, and it's just not real great. So what I'm going to do is I'm going to clean the heads again, because we know from experience sometimes you have to double clean them. Let's just see if that makes any difference at all. Nope. And what I'm seeing on the oscilloscope there is a marked difference in the tracks. That was 80 or 79. This is 0. Nice amplitude there. The middle track 40 is just rock steady. And then you go to 79. So if anything, it's biased toward the middle. So I don't know. Let's give it another test and see. So far, so good. There's no reseeks at all. Battery backed up clock not found. What? That's weird. Oh, it's 1.2. Doesn't look for it. All right. Before we get too far, let me just make sure I've got these screws cranked down. Yeah, I think so. Just a little love tap. Let's try the alignment system program disk. So that's interesting. It really depends on the drive you're working on, but at least on these Panasonic ones, you want to go to track 40 and get a nice steady, not a jumpy, but a nice steady signal. And then if you need to align the two, the top head with the bottom head, you can go from there. And that's actually where the Amiga test kit comes in handy, because I couldn't see any change, at least on the Panasonic, for me messing with the top head. I could move it way out of whack and it would just show the same thing. Tell you what, working on these floppies just takes a lot of patience. Let's try Ebon Star. So the Panasonic drives, I'm thinking, are a little flakier than the others. That's my theory. I'm sticking to it. Yeah, I'm sure that's going to continue to work. Let's take a look at... This is definitely the closest this drive has gone to working though. Just kind of curious as to, I mean, that made it all the way to the end track. This is a 2091 setup disk that I'm pretty sure I had problems with before on this drive. Because I wrote possible bad disk on there, so I'm going to cross that out, not so I can't read it, because there still might be a possibility of that, but Um, you know, it's funny because some of these games I wrote using this drive. So I'm going to rewrite these disks using another drive and see if they start to work. So we're just about done here. I used a Chinon drive to make all these disks, make all these backup disks. This is the drive that I used to make these disks originally, and as far as I can tell, and then when they may have been able to be read by this drive. Well, actually they weren't. So it's weird because usually when you make disks with a drive, you can, you know, when you write to the disks on the drive, you can usually read because it's the same misalignment is in place, unless it's really far out. So, but this Matsushita Panasonic is I'm going to consider it to be a working drive 100%, except it's not the best idea to use it to write with. Every single one of these disks that didn't work before, there's 5 or 6 of them, I got to work by rewriting them using a Chinon drive. So I copied the backups onto this again. I reused the same disks, and now they all work. So that kind of tells you that this drive was sick, and now it's at least reading disks pretty reliably. As long as the only disk that it won't read now is this one, and this one seems to have some kind of mechanical incompatibility. It just goes, there's something rubbing in the drive, and I remember having that happen back in the day. So anyway, yeah, every single one of these games did not work, so that wasn't yeah. Anyway, they all do now. This one comes up with a glitchy graphics because I think it's a PAL game, or yeah, I think that's probably what it is. So anyway, thanks for watching. We'll see you on the next one, friends.